Online.
Hello students, welcome to Darasa Online. I'm very happy to connect with you once again. My name is Naftal Lucas, and today I have another very good presentation, and the presentation is coming from the topic of extraction of metals. And the subtopic that I'm going to focus today is the extraction of metals by electrolytic reduction and thermal reduction. So we are going to focus on these two particular subtopics: extraction of metals by thermal reduction and by electrolytic reduction. That means we are going to cover the all parts, because from this particular part we are going to discuss different questions. We are going to see how different problems can be solved using the knowledge from this particular part. So I'm sure that by the end of this particular presentation, you'll be able to apply the chemistry knowledge to solve different problems. And also you'll be able to use chemical formulae, symbols, and equation to communicate in chemistry. Now, my dear students, because we are going to discuss about the extraction of metals regarding to this particular part, we need to understand what is all about extraction of metal. If I ask you what is about the extraction of metal, what are you going to say? I'm sure that you have studied this in the class. So, extraction of metal. We can generally say this is a stepwise process through which a metal is extracted from its ore. Or you can simply say, is the process through which a metal is obtained from its ore. Now, when you talk about the metal occur naturally either in free state. That means sometimes a metal is extracted from its nature, free, not combined with other elements. But also, it can be extracted combined with other elements. So there are two forms. The metal can be extracted or can be found in free state. That means not combined with other elements. But also it can be obtained combined with other elements and associated with other impurities. Now from there, my dear student, we can ask yourself, here we have a mineral and we have the ore. How can you differentiate between the two? For example, we have clay and we have the bauxite. These are two minerals. But one of these two minerals we can use it to extract aluminium, and that is bauxite. So bauxite, this is an ore. and the clay is just the mineral. So here we can get the difference between the ore and the mineral. When we talk about the mineral, we are talking about the natural material which is found in the Earth's crust, from which a metal is found either in free states or combined with other elements. And when we talk about ore, we are talking about the chosen mineral from which a metal can be extracted in a large scale. So that is how we can differentiate between the two. As I said, for example, the bauxite is used to extract, we can extract the aluminium from the bauxite ore. So bauxite is the ore, and the clay, which is another mineral from which aluminium can be found, is just the mineral.
You are watching Darasa Online.
Now, my dear students, from there, we can proceed discussing about how to extract the metals. I hope that you have started in the class. We are just doing a revision so that we can solve different problems. Now, there are general methods of or steps that can be used to extract the metal. The following are the steps which are used generally to extract the metals. Number one, we have the concentration of the ore. Oh, this is called the concentration and the mining of the ore. Number two, we have calcination and roasting. But number three is reduction of the metal compound into the metals. But lastly is the purification of the metals or refining of the metals. Number one is concentration of the ore. Step number two is calcination or calcination and roasting. Number three, we have reduction of the metal compound to the metal. And the number four is purification of the metal, or in other words we say refining. We can see each of the steps so that after discussing this one we can go and see different methods, different questions relating to this particular presentation today.
You are watching Darasa Online.
Now, starting with the first one, concentration of the ore. When we talk about the concentration of the ore, what do we mean always? What do we mean always? Concentration of the ore, this means involve the removal of the earth impurities which are associated with the ore. Now this one that is step number one. The removal of the earth impurities which are associated with the ore. For example, we have sand. Sometimes an ore can be associated with the sand. Sand is not wanted. We want the ore. and from the ore we wanted the metal. So sand is an impurity. It is not wanted. Sand, for example, in the iron ore. From iron ore. Now, here there are terms that it is very nice for us to understand them. The first term that we can discuss from this particular part, we can discuss about the gangue. What are these about? When we talk about the gangue, we are talking about the earth impurities which are associated with the ore. That is the meaning of gangue. Just like I said here, for example, sand is a gangue. That means it is found contaminated with iron ore. Here, can take it here. Sand. There is another term also is important for us to understand. We have the flux. Is another good term to understand in this particular step. When we talk about the flux, we are talking about is the material that combine with the impurities of the metal. So after the metal is extracted, sometimes it can be contaminated with the impurities or other metals that are not wanted. So we remove them. So flask is the material that is added to react with the impurities from the metal to form the slag. For example, we have calcium oxide. This calcium oxide is obtained from the decomposition of calcium carbonate when extracting iron using hematite ore, that is the iron 3 oxide, which is the ore of iron. Now that is flux. From there, we can also have another one. We have slag. When we talk about slag, we are talking about the fusible or the molten material formed by the reaction between the flux and the gangue. For example, calcium silicate. Calcium silicate is an example of slag. So if we have calcium oxide from the decomposition of calcium carbonate, when the calcium carbonate is added in the furnace, when extracting the iron using hematite or iron 3 oxide, this one, flux, react with the gangue, that is silicon dioxide. This is the sand, producing the slag, and this is calcium silicate. So you can see in this step of concentration of the ore, we have these three important things that we can do. So the removal of the ore in the impurities of our can say the earth impurities from the ore is the first step that is done when extracting the metal. So these processes are done even in those machinery that are used to extract metals. when you go to Geita Gold Mine, they are just following these ways of getting the metal from the ores.
You are watching Darasa Online.
Now from there, we can have some more steps to do with the extraction of metals. The second step, after concentrating the ore, that means we have removed the earth impurities which is associated with the ore. Now we need to get the pure ore so that other process of extraction can proceed. Second step. Now the second step is calcination and roasting. What is happening and what is the difference between them? Calcination aims at removing the moisture from the ore. It also removes the water of hydration and also removes some volatile substances from the ore. This is done under limited supply of oxygen. It removes moisture. It also removes and these together, they are removed by this process of calcination. So this is done by using a limited supply of air. Now the calcinated ore, after removing those things, it is subjected to roasting. And when we talk about roasting, this involves the heating of the concentrated, the calcinated concentrate in excess air. We are using excess air below the fusion temperature of the metal ore. So this process also, it aims at the following. Aims of this one. Number one, to dry the ore. It dries the ore. It makes sure that the ore is dry. Also, if the volatile substances are still present, they are removed by this process. But the third one is to transform the metal ore into the oxide. This is the aim of roasting. Now, if the metal ore is already in the oxide form, there is no need of roasting. So this is the second step that we have. Now from this one, we can go to the other step.
You are watching Darasa Online.
After calcination and roasting, what happens next? We go to the third one. The third one is reduction. And today, particularly, we are going to discuss about the three. Reduction of the metal oxides to metals. Now, there are different ways of reduction. We are going to discuss about this, different ways of reduction. Now, from here, my dear students, we can have this different method of reduction depending on the reactivity of the metals. Now, from here, we can have the first one. The first one is thermal reduction. Just like the word it reads itself, thermal, that means this involves heat. So this method of reduction of the metal oxide involves the oxides of the metals which are found at the bottom of the reactivity series. That means it is concerning with the metals which are less reactive. That's why they are found at the bottom of the reactivity series. So what is done here is just by heating their oxides, those oxides into metals. For example, mercury oxide can be heated at the temperature of 300 degrees Celsius to form the mercury. Yes, this involves the reduction of oxide of metals which are found below the reactivity series. For example, just by heating. For example, mercury oxide. When mercury oxide is heated at 300 degrees Celsius, we get the mercury metal. That is thermal reduction. Now, from that is one of the ways of reducing the metal oxides.
You are watching Darasa Online.
The second method of reducing metal oxide to metals is chemical reduction using carbon. You have studied this one in ordinary level. Reducing metal oxide using carbon. This is called the coke or charcoal. For example, zinc can be obtained from zinc oxide by using carbon. Now, this is chemical reduction using carbon as coke or charcoal. We have another one. Chemical reduction using carbon monoxide. This can be used. For example, when extracting iron from the hematite ore, the most reducing agent is carbon monoxide. this one. So carbon monoxide is the main reducing agent in the furnace when extracting iron. So it can be used to reduce this hematite ore, which is iron 3 oxide, to give iron. That is another reduction. Another reduction that can be used here is by using a more reactive metal. For example, chromium can be extracted from chromium oxide by using aluminum metal, because aluminum metal is more reactive than chromium. This is called thermite reduction. For example, chromium by reducing chromium oxide using a more reactive metal. That is aluminum. So this is a thermite reduction. It can be used as a method of reducing metal oxides into metals.
You are watching Darasa Online.
Another method that can be used to reduce the metal oxide to metals is self-reduction. This is number 4. Number 5, we can have self-reduction, or it is called auto-reduction. Now here, this is involved in the reduction of the sulfide ore. It can be used. Now when the ore is oxidized, it can give the oxide. That oxide can be used to reduce the rest of the ore. For example, when we have copper 1 sulfide, this when oxidized, it gives copper 1 oxide and sulfur dioxide. Now this copper 1 oxide formed, it can be used to reduce the rest of the ore, that is copper 1 sulfide. This is what is called auto-reduction or self-reduction. So here we get copper and sulfur dioxide. From here you can balance. Here we have 4 copper, but for the case here we have 1 copper. You can go to other one. Here we have 1 oxygen, we have 2 oxygen, so you put 2 there. So we are going to have 4 copper, and this one you are going to get 6. So we put here 6. And the sulfur here is 1 and there is 1. There is no problem. Oxygen, we have 2, we have 2. And this one we have 2 copper, we have 2 copper, there is no problem. Sulfur we have 1, we have 1, there is no problem. And how about oxygen? We have 2 and here we have 3. So what we can do, we can put here 2 and you put here 2 and you put here 3. When you balance this equation, you're going to have 4 copper, and this side you are going to have also, you put it there 2. You're going to have also 4 copper. For the case of sulfur, 2 sulfur, we're going to have 2 sulfur. Oxygen, we're going to have 6, and here also we're going to have 2 times 2, we're going to get 4, and this one we're going to get 6. So this is auto-reduction. It used to reduce the sulfide ores. Now from there, we can have the last one. This last one is called electrolytic reduction. Electrolytic reduction. Now, for the case of electrolytic reduction, This is used to extract reactive metals. These reactive metals can be found from group 1 and also from group 2 and group 3. For example, we can have the potassium, sodium, calcium, magnesium, and aluminium. These are reactive, so they can be extracted by electrolytic reduction. But why? A common reducing agent cannot be used to reduce the reactive metals from group 1, group 2, and group 3, because these are the strongest reducing agents. So they need the strongest method of reduction, and automatically that is electrolytic reduction. Stronger reducing agents. Therefore, they need the strongest method of reduction, and the strongest method of reduction is electrolytic reduction. And this method is used using the fused chlorides of these metal compounds or their oxides. So we'll be back after a short break to see more explanations on this particular part and some more examples. Don't go away.
You are watching Darasa Online.
Now, my dear students, welcome back. After we have seen the introduction of this particular part, we have seen the general steps of extraction of metals and the chemical reduction method. So it is the right time now to focus on the competence-based questions. The question is how the questions are coming from this particular part. That is very, very important. Most of the students are failing to answer these questions because they miss some knowledge of answering these problems. So let me take you to these particular examples to see how the questions are coming. Now let us be together. Now we can see question number 1. Question number 1 here. Question number 1A. It says, explain why extraction of group 1A elements is done by electrolysis and not by using reducing agent. That is the question. My dear student, can you see that question? It is very simple. You can do it. Yes. Explain why extraction of group 1 element is done by electrolysis and not by using reducing agents. We have studied together from the introductory part of this lesson that group 1 elements, group 1A elements, are strong reductants. If they're strong reductants, they need the strongest method of reduction. Now, these reducing agents, which are very common, like carbon or carbon monoxide, they are not strong enough to reduce these strong reductant or reactive metals. So electrolysis is the strongest method which can be used to extract these reactive metals, or can say the strong reductants. So that is how you can answer this problem. I'm sure that we are together, and I'm sure that you are following. That was question number 1A. We can go to question number 1B so that we can see how another form of the question can be. Just look here. Members of group 1A to group 3A of the periodic table are normally extracted by electrolysis of their fused chlorides. Explain why chlorides are used and not any other compounds. That is also another good question. very important for you to understand. If you meet with that questions, what are you going to do? How are you going to answer that question? It is very simple. Now, why chlorides? Why the ores of these compounds are always chlorides? Mostly. There are three things you have to understand about chlorides. Number one, chlorides have relatively low melting points. If that is the case, they can easily be melted. So this gives a very important reason for the metals of group 1A to group 3A to be extracted easily from the ores of chloride. That is reason number one. But reason number two is that chlorides, they are highly ionic. If they are highly ionic, that means they can be easily electrolyzed. The process of electrolysis can take place easily. So that becomes another reason to explain why extraction of metals of 1A to group 3A, the chlorides are used and not another compounds. That is important. But the third reason that you also use to answer this problem is that chlorides are purest. So if that is the case, they can be crystallized in their purest form. And when we want to extract the metal, we always want to have the metal which is very pure and from the purest ore. So chlorides are in that form. So those three reasons, you can use them to answer that particular questions. It is very important for you to know this as well. So that was question number 1A and B. So let's proceed to another question.
You are watching Darasa Online.
The second question here on the board says, explain why A, alkaline metals are extracted by electrolysis of their fused ore and not by reduction process. If you look at this particular question, alkaline metals are extracted by electrolysis of their fused ore and not by reduction process. That question is similar to the one that we have answered in the previous questions. So the answer is the same. That is another different form the question you might meet with. So it is important for you to note these differences, ways of answering questions. You may meet with the questions which is similar to the one that you know, but you fail to answer it because of fear or because of lacking some knowledge. So they are the same. So that is, part A. Now from there also we have B. Chlorides in most cases are used as ores for extraction of alkaline metals and not oxides. Can you see that question as well? That question also is similar to the one that I have given you the reasons here. It is very similar. It is not different. So it is simple. Giving the reasons why chlorides are mostly used as ores for extraction of alkali metals and not oxides. I have given it 3 reasons. Now, can you memorize those 3 reasons? You have to memorize them, but understanding them, that is very important. So the question also might come in that particular form. Now we can proceed with other question to see how also the questions might come from this particular presentation.
You are watching Darasa Online.
Question number 3A says, describe the types of reduction process involved in the extraction of metals and give one example of the metal involved. Now, my dear student, that is also another simple question that you can meet with. Here, you are told to describe the types of reduction process. Now, if we were together, and I hope so, in the presentation, we have discussed about the method of reduction, different methods, about 6 methods of reduction. This method of reduction depends also on the reactivity of the metals sometimes. For example, number 1, if you remember well, Number one, thermoreduction. In thermoreduction, we said that the metal oxides, the oxides of the metals which are found below or at the bottom of the reactivity series can be extracted by this method. That is thermoreduction. For example, mercury. You can reduce mercury oxide into mercury by just using heat alone. That's very simple. For example here, mercury oxide. This one can be heated to about 300 degrees of Celsius to get mercury and oxygen gas. Therefore, my dear students, you can try to take a piece of paper and balance this simple equation. So that is thermoreduction. That is number one. But number two, we have chemical reduction by using coke. Coke or charcoal. That means that is carbon. When we talk about coke or charcoal, that is carbon. For example, you can obtain zinc by reducing zinc oxide using carbon. It is very simple. That is number two. Number three, chemical reduction by using carbon monoxide. For example, hematite, which is iron 3 oxide. You can get iron by reducing that ore using carbon monoxide. So it is simple. Another one is auto reduction or self-reduction. This is done for the sulfide ores. For example, you can obtain copper by auto reduction. We have seen that already in our discussion. We have also another reduction, that is thermite reduction, thermite process. You can extract metals by using a more reactive metal. For example, you can get chromium from chromium oxide by just using aluminium, because aluminium is more reactive. So aluminium reduces chromium oxide to get chromium. So it is simple. But lastly, you can also get the metals by reducing their compounds using electrolysis. That means electrolytic reduction. This is used for the extractions of reactive metals, which are from group 1A to group 3A. So I'm sure that you remember this. It is important for you to remember them. Describing one after another with a short description and give examples. It is important. It is not just the matter of giving a short description, leaving as it is. No, you have to give the example of the metal which is extracted using that method of reduction. So, my dear student, it is important for you to answer that particular question. Now, after we have seen question number 3, part A, we can go to question 3 for part B.
You are watching Darasa Online.
The question says, describe any 3 physical methods of concentration of the ore. Give one example of to each method. That question is also very simple, my dear students. You can answer it in a very simple way. A concentration of ore, as we have seen, this stage involves the removal of earth impurities from the ore so that we can get the pure ore for the other process of extraction to proceed. Now, if you are given that question to describe those 3 methods of concentration of the ore, the methods which are used to remove those earth impurities, what are you going to do? Let us describe together those 3 physical methods. Now, the first one that we have is magnetic separation. magnetic separation is one of the method of removing the impurities from the ore. And this is done to separate the magnetic impurities from non-magnetic ore. For example, tin stone, which is the ore for tin. This one is non-magnetic ore, but its impurities like iron, manganese are magnetic. So we can use a magnet to attract those magnetic impurities from this ore. So by using that one, we leave the ore without those impurities. So that one. That is one of the physical method of removing the impurities from the ore. It is important. Now this one, the second one, we have also the gravity method. Gravity method. This gravity method is used especially for heavy oxide ores like which is iron ore, that one. We can remove the sand impurities and other earth impurities associated with this one by gravity method. Now what is done? The ore is crushed into powder. Now the powdered ore is taken on the sloping floor and a current of water is passed. We remove the light sand particles and other earth impurities, leaving the heavy ore particles behind at the bottom. Now here we can have this illustration here. Now this is a current of water which is passing. So get this beaker. Here we have water and we have the gang particles. Which are earth impurities removed from here by being washed away because they are lighter than the ore particles which are left behind at the bottom, as you can see here. So these are all particles. They are left behind because they are heavy than this one. So it is simple for you to do this problem. So this is gravity method. Now the last one, my dear student, that we can see from this particular part, how to remove the earth impurities from the ore. The last one is froth flotation. This is another one. Now, froth flotation, this is used to remove the impurities from the sulfide ores, like copper sulfide, lead sulfide. These are used here for sulfide ores. And lead sulfides. Now, these ores are associated with impurities. How the impurities are removed? It is very simple. Here, what is done is to remove those, the impurities which are associated with these ores are always hydrophilic. That means they are weighted by water. But these ores themselves are weighted by oil. That means they are hydrophobic. So what happens is that the powdered particles of these ores are mixed with water, followed by addition of pine oil. From there, emulsion will be agitated by compressing with air. This causes the oil and the froth to come and float on the surface along with the ore. From there, the froth is taken, and from the froth we can get the ore. Now, from here, the impurities which are associated with this one can be removed from these ores in that way. So other process can proceed. So these are the three methods of removing the earth impurities from the ore. We say that there are methods of concentration of the ore. So it is very important. Now, my dear student, these are some of the examples of the competence-based questions that you may meet with. It is very important for you to answer in that way. You explain, giving examples. Extraction of metals is very important also for you to understand the importance of metals in our daily life. As you can see, most of the precious metals, most of the precious things are made of this one, including the chains, jewelries, and the other things. They can be made out of this one. Iron sheets, they can be made from metals. Utensils are made from metals. So pipes are made from, for supplying water, are made from metals. So these metals are used daily in our life. Let's take this opportunity to thank you for being with me. What I want you to remember, make sure that you remember the method of reduction. I have told you. Make sure that the method of concentration of the ore is important. Make sure you know the general steps of extraction of metal. It is important to explain each and everything that I have told you by giving examples. So next time we shall proceed with the other series of discussion. Thank you very much. Have a good time. Bye.